In this video, we want to implement a circuit using the microcontroller 8MeGA32, such that the microcontroller is connected to a set of 8 switches and 8 LEDs. Each LED should only light up when the corresponding switch is closed, and otherwise the LEDs should turn off. So let's begin. Here is the our𝜇 Studio software. So we will begin with creating a new project, file, new project. Then here we will choose GCC C executable project because we will write a C code, and also we want the project to be executable so we can burn the code on the our𝜇𝐶 microcontroller. Here we can change the name, so I will write it as 8 switches, 8 switches, and LEDs. Then press OK. Here we will select the microcontroller. We will write here on the search 8MeGA, 8MeGA32, and here it is. As you observe here, so the memory location is 32 kilobytes, and the data memory bytes is 2048, and the EEPROM 1024 bytes. So click OK. So the project is finalized, and here you will see that the hash include avr/io.h. This is the header file, contains all the definitions for the input-output ports of the microcontroller, the 8MeGA32, and this is the int main. So let's go to copy our code here. I have prepared it before. Here is the header file that we told about the IOs, and this is another one for the definitions of the other registers. And here, as you see, we defined our frequency of the CPU inside the 8MeGA32. Here, if you read on the datasheet of the 8MeGA32, we will find that it works from 1 megahertz to 16 megahertz. So here I will use the maximum frequency, which is the 16 megahertz, but you can use 1 megahertz or something on between this range. Yeah. L stands for long byte, and here is the slash include utl slash delay.h. This is the function for the delay. We will not use it in this code, but this is for the sake of for your information. And let's begin. Here we use the register of the data direction register, the DDRA. We put the value of 0xFF to make all the bands of port A output, because we will use it for the 8 LEDs. And here the DDRB, the data direction register for port B, we put all the values as a zeros, so we will make the port B is an input. For this project, we will use the mechanism of pulling up resistor. We will initialize all port B, which will be connected to the switches, to be equal 0xFF, which is 8 ones. So by making this, when we connect our resistor to the side of the voltage source, which is the 5 volt, so our switch will be pulled up, and the switch, when it's unpressed, the value on it will be a 0 volt, and if we press the switch, the value will be a 1 volt. So for this sake, we use the function of the bit is clear to check the values on the port B, the input values, using the register BNB. And for this sake, if we press the switch, so the value received by the bins of port B will be a 0. So if these values will be a 0, we will send a 1 on the switches that will be pressed. Else, we will write a 0 on the port A, so the LED will be off. This for loop, we use it so we can check all the switches one by one. So here, if the I equals 0, so the I here will be 0. So we will check only the first switch connected to bit 0 on port B. And if this function is okay and the condition is yes, so the on port E we will write on BA0, which is bit 0 connected to the first LED, we will write here a 1. And if this condition is not true, so we will write on this bin as a 0, and so on until we checked all the switches and by the while one loop, so the project will be executing until we power off the circuit. So let's check this code by clicking build solution. So here I think we lost a bracket, so we will put here a bracket, and I made that to show you that the errors here in the error list, and if we make an error, so it will be obvious here, and the execution of this file will be failed. Now we will rest again, build solution. So the error disappeared, and they write like build succeeded, so that's okay. Let's go to check the folder of our project. So here we will go to desktop, and our folder is the first one here, 8 switches underscore 8 LEDs. So if we go inside, we will see the folder of the debug. Here, as you see, there is a file is produced, which is the same name of the project, .hex. This is the file that we will burn we'll use it to burn on our code on the our𝜇𝐶. Okay, so here we define the location. So let's go to our𝜇𝐶 IDE to burn our code. Here's the our𝜇𝐶 IDE. This is a new sketch. So firstly, we will put our switches. So we can make the orientation of the pull-up resistor. So here we will bring here on the our𝜇𝐶 IDE, this is the tab of switches. So we will go here and put our switch. So this is small, so we'll make like a zoom in. We can right click and then zoom fit, and then where are you? So okay, so we will click on that to move it here. Then we will put like 8 switches. You can press here like copy, so you just copy the switches. and then we'll make the orientation. Okay, so this is 4 and we need the, okay, so this is our, so this is the first one here, here, this is the second one, and this one, and this one. Okay, so to make the pull-up resistor orientation for the switches, so we should put this side to ground and the other side with a voltage. So let's go for the ground here and to go like this one and connect all of them to the ground. So we will press and then we'll go here, press, and then we will go down to connect this switch with the ground like this, and this be like that. Mm. Okay, so now we connected this side for all the grounds, and this side we want to connect it with a 5-volt then resistance to pull up the switch. So to have a fixed value for the voltage, we will go here for rail and pick it like this one. Okay. And then we'll go for this, our resistor here. So if we make like this, we connected that one. This terminal here. Okay. So we will repeat this to all the switches and before we connect it to our microcontroller. So we connected all the switches. Now from this terminal to ground, and from this terminal we connected to a 5-volt followed by the pull-up resistor. So the status of the value on this line with the switch unpressed, it will be a 1, and when we press the switch it will be a 0. So let's go for the 8MeGa32. So here in micro AVR 8MeGa, this is our 8MeGa32, so we will put it here and begin to connect all of that to the port B here. So from here a wire, we can stop like that and then stop here and then continue. So our sketch will be more organized and the circuit will be looking more organized. then stop here and then connect like this. And this switch also stop here and here, and then this switch stop also here. Okay, so in this side we connected our switches to port B in the 8MegaHz32, and we should connect to the reset button. So the reset button is is an active low. So if we connect to it a ground, so it will be working, but we should connect to it a VCC with a resistance, so we can make like this, that we want to copy that. So and press copy, and here we can put them and connect it directly. That would be too far. This good. Okay, and here we connected to the reset. So we connected the port B to the switches and the reset bin to the resistance and VCC. So now we want to connect the LEDs. So we will put a resistor here, put like 8 resistors, so we can make right click and put here the resistor. So like that, and then we will organize them. We 1, 2, 3, 4, 5, 6, 7, and another one. So here put the 8 resistor as like this. Okay, so here we have 1, 2, 3, 4, 5, 6, 7, 8 resistors, and so we will connect them directly to the bins of port A. Here, this one, and this one. Okay. Okay, so let's go to bring our display. We will use a LED. So we put here a LED. We can make a copy also. So I want 8 LEDs. 1, 2, 3, 4, 5, 6. We want 2 more. Okay, so here this one, this one, this one. Okay, so when we connect them like that. Okay, then we will bring a common ground and put it here and connect all of them to ground. So here, you can remove the wires by pressing on it and right click. So this one I make like that, click. Okay, here also, here, and then press click and connect it to that one, and here connect. Okay, so here all the hardware are done, and we want to burn our code on the microcontroller. So we will go to the microcontroller and press right click. You'll see many options. We will click load firmware. So we will go to our file on the desktop, 8 switches and 8 LEDs. And here, folder of debug, we will go to hex, open. And here in the commander will say firmware successfully loaded, so it's okay. Then we will make press. Okay. So we want to see if what's the value before we press the switch. So we can bring from here a probe and, for example, put it here. Okay, wow. You'll see here before closing the switch, when the switch is unpressed, the value going to the microcontroller is 5 volt. So if we press the switch, the value will change it to a 0 volt and goes to the microcontroller, and the bit is clear function will see if the condition is true or false. Here the switch is pressed, so the value is 0 volts, so the condition will be true and the LED will be on. So here we explored that our code is working well on the microcontroller. So for example, if we click this one, also it will be the corresponding LED will be on. We press this one, also the corresponding LED will be on. And that's it, and thank you. See you in another video.